Hello everyone, happy to welcome you all the 9th successful episode of Why Not series. Our topic is end-arm tooling for next generation factories. Excited to be having a session on such a cutting edge on niche tech topic today. So I want an inspiring quote I read from Mr. Jeremy Jurgens, Managing Director of World Economic Forum. Mr. Jeremy told, from income inequality to climate change, technology will play a critical role in finding a solution to many of the challenges our world faces today. Emerging technologies demonstrate the rapid pace for human innovation and offers a glimpse into the what a sustainable, inclusive future will I look like. Yes, the new technology we need to, the climate will be changing every day very drastically. So we need to adopt our new technology. Mankind has seen several significant development in the industrial practice, starting from the advent of steam engines that in the first industrial revolution. Today we are witnessing the industry 4.0 or fourth revolution with embracing the intelligent production. So the focus is on dynamic and smart process for the factories of the future that ensure the operational excellence for industries. Yes, technologies are not only helping the industry become more efficient, but are also providing the solution to the many challenges in front of the humanity today. Okay, so we are living in very existing time where we can see the advent of several new technologies that will shape our future: connected devices, autonomous vehicle, robotics, 5G, Wi-Fi 6 technology, cloud, edge, quantum computing, big data, etc. etc. A lot of new technology upcoming days. It will be evolving day by day. All of these technology have impact across the all sectors. In addition to manufacturing, today we are excited to the having Mr. Samad Ozur from Zimmer Group of host the session on end-arm tooling for robotics. Zimmer Group, German multinational company. The German multinational company headquarters in Germany was established in 1980 and are currently presented in 129 countries worldwide. Zimmer is a global leader in pneumatics and electrical handling components in industry. So we are using Zimmer, very fantastic product. So they are pioneers in development and manufacturing of components of solution for handling robots, including end-arm tools, especially for gantry automation, and machine tool automation. They have a fantastic R&D team has created the explanatory innovation in process automation. Since 2013, they have been positioned as the know-how factory that support the customer in the age of digital transformation. They have a educational segment also. They have a working with education segment also to impart their expertise and knowledge to the future generation on the field of pneumatics and electrical handling. So we invite Mr. Samad also to start the session. Sir, the floor is yours now.
Yeah. Thank you very much, sir.
Thank you.
Good evening, everybody. And firstly, I would like to thank Elingwaran sir for giving us this opportunity to understand in detail about the end of arm tooling. So thank you for your brief introduction about Zimmer. And to begin with, the main agenda for today's session would be the end of arm tooling and how it plays a pivotal role in handling the applications or in terms of automation. So we begin with, just a brief history about Zimmer Group. Zimmer Group is basically from Germany, started way back in 1980. We are a 40-year-old company at the moment, and the founders are Gunther Zimmer and Martin Zimmer are the founders of Zimmer, and currently Mr. Achim Gauss is the managing director of the Zimmer Group. This is just a brief about Zimmer Group. This particular says how Zimmer started in 1980 and how it evolved with different components in terms of the demand of the industries. So in 1980, we started building these grippers, the end of the arm tooling, which we will study a little more in detail going further. So as on when a year started, 1999, 2004, 2007, year on year, we started developing new products which are compatible to the current industries. And in 2014, we clubbed all the units into one roof that we now call it as the know-how factory. Zimmer Group, the know-how factory. Why we call a know-how factory is we not only build components, standard components, we also build the customized components in terms of the handling components. We completely build the customized solutions as well based on the requirement of the industries. Yeah, this particular chart tells us how the development of Zimmer Group has taken place from 1980 till now. You can see at the bottom, so in 1980, if you can see, we have developed the crudest gripper, and in 1990, we developed tool changers. We have built shock absorbers for end cushioning. And today we have one of the most sophisticated end of the arm tooling that is portable, suitable to the industry 4.0 or the next generation factory is what we can call. So moving ahead, these are some of the facilities which we have back in Germany. The bottom Salmenkopf and Glockenleck is our production facilities where we produce all these end of the arm tools, and Ottweiser is one more a new production facility back in Germany, and Ettlingen, which you can see over here, is a sales office in Germany. So at the moment we have a presence in 129 countries including India. In India we are operating in Bangalore, in Chennai, in Pune, Delhi, Gujarat, and we have headquarters in Pune at the moment, but we have no sales offices or the corporate offices across 5 different cities at the moment. The core of today's session would be the smart end of the arm tooling. What do you mean by the end of the arm tooling and how it plays an important role in terms of automation or in terms of the next generation factories or the industry 4.0, what we usually call as a industry 4.0. As you can see, there's a excava robot and you have the grippers. These are your end of the arm tooling solutions. So what I would like to tell you is in this modern age of digital factory, a lot of robotic systems are deployed in day-to-day production of variety of production. Variety of industries you can consider, may it be automobile, may it be pharmaceutical industries, may it be food and beverage industries. There are a lot of robots which are being deployed for the production of the variety of products. So now we can tell as robots have become a commodity, and the most important part of this robot would be the end of the arm tooling solution. What do you mean by end of the arm tooling solution? As you can see from the picture, the devices, these are the devices which are attached to the end of the arm. This is the end of the robotic arm, and these are the devices which are being attached to the robot. These are the end of the arm tools, which plays a major role in handling applications. These are basically designed and used to act as a robot wrist to interact with the components or to interact with the machines or the other systems in the entire production line. These are the components which comes in contact with the component or which comes in contact with the machine. Let's say we talk about a machine tending application wherein we are handling a cylinder block. These grippers will come in contact with the component, pick the component, and then places inside the machine for operation. So these are phenomenally or in generically called as grippers, because these will help in gripping the components. You can see there are 2 jaws. These are the jaws of the grippers. And this is the gripper. This is your gripper and these are the jaws of the grippers. This is just schematic representation or just a view of how exactly the gripper looks. It looks as similar as your hands. You can imagine your hands as 2 fingers of a gripper, and then you can just try and analyze how we can use these grippers in the industries for gripping applications. Moving ahead, this is some of the technologies Zimmer Group operates in. Zimmer Group operates in handling technology, builds components in handling technology, damping, linear system, and all these technologies. We develop the components for all these 5 to 6 different technologies at the moment. So today, specifically, we are going to talk about the handling technology. What is handling technology? When we say handling technology, it will be the grippers. When we say grippers, it will be the end of the arm tooling. End of the arm toolings are nothing but the grippers which are fitted to the end of the robot arm. So we talk a little more in detail about the handling technology, what are the types of grippers we have and how it can be used and for what kind of applications it can be used. So we will study a little more in detail about these things going ahead. So followed by that, we'll also quickly look at the construction of the gripper, how exactly, what are the mechanism involved in the gripper, and this particular slide shows you the construction of the gripper. Basically, when we say grippers, there are two types of gripper. One is 2-jaw gripper as well as 3-jaw gripper. 2-jaw will have 2 fingers and 3-jaw will have 3 fingers. Now we can see this is the area where the finger comes out, 1 finger, and this is your second finger. This is a 2-jaw gripper. You can see this is the wedge mechanism, we call it. This is the wedge mechanism. So on supply of pneumatic air, 6-bar pneumatic air, this cylinder will push this particular piston. This is a piston. This is a piston which moves and then the jaws open up. Similarly, in case of 3-jaw, there are 3 jaws, 1, 2, and 3. There are 3 jaws for a 3-jaw gripper, basic, and it operates based on the pneumatic air as well as the electrical supply as well. So we'll go a little more in detail about the types of 2-jaw grippers as well as the types of 3-jaw grippers which are available. So I hope this is pretty much clear. When you pass an power, this particular cylinder will move the piston. This is your piston. It moves and the gripper will open up, open and close. That's how the basic mechanism of the gripper works. Yeah. Now let us talk about one particular series of gripper. We have this gripper series 5000. So in this particular series, we have 3 different types of grippers. Again, one is 2-jaw parallel grippers. Why we call parallel? Because the gripper fingers will open in parallel fashion. 2 grippers will open in parallel fashion. One in this way and one more in this way. So we call it as a parallel moving jaws or parallel operating gripper. Then we have 3-jaw grippers, wherein the opening of the gripper will be in concentric fashion. And we have 2-jaw angular grippers. This is the opening of the jaws will be in an angular fashion. Angular in the sense the opening will be in terms of degrees. So again, what is the mode of operating and how do you operate these grippers? One is the pneumatically operated, one more is hybrid operated, and one more is electrically operated. When we say pneumatically operated, we have 6-bar pressure to operate these grippers. On supplying 6-bar pressure, this gripper will open and close and will help in gripping the components. And in hybrid, we have the actuation of the particular gripper is again with the pneumatic air, but you will have an electrical feedback. That is the reason it is called as hybrid, because actuation is pneumatic and you will have an electrical feedback. And one more is the completely electrical version, the most sophisticated grippers or the industry 4.0 grippers. These grippers are operated by a BLDC motor as well as the servo motor. So 24-volt supply is what is required to actuate the electrical grippers. So this particular actuation of the gripper in terms of pneumatic, hybrid and electric remains same for 3-jaw gripper as well. Only the difference is we have 3 jaws here instead of 2 jaws. So pneumatic, hybrid and electrical remains the same. In angular gripper, we have only the pneumatic version. Here the gripper opening will be in terms of degrees. As I said earlier, in terms of degrees means 0 to 10 degree, 0 to 15 degree opening. So this kind of opening is in terms of angular fashion. So the this particular model of gripper is called as 2-jaw angular gripper. So I hope the different types of gripper and the different actuation of the gripper is pretty much clear. We have 2-jaw gripper, we have 3-jaw gripper, as well as 2-jaw angular gripper. So again, the actuation is 3 types. One is pneumatic, one more is hybrid, and one more is electric. Electric is again 24-volt supply. So I hope until now, the part of the gripper is pretty much clear. So we'll move ahead and study a little more in detail about this particular type of a gripper. Now we are exclusively talking about the gripper family 5000. This is one of the sophisticated or the premium class of grippers, we can say. Why? Because this has got a lot of advantages when you compare anybody in the market. So we have the corrosion protected gripper. The body of the gripper is stainless steel. The body of the gripper is stainless steel, steel on steel. This is the guidance. As you all are from electrical as well as from the mechanical departments, so you understand much better about the friction. So when you have a steel on steel, the friction is less. When the friction is less, the gripping force is more. So that is why this particular wedge mechanism, where you can see this particular is a steel, wherein your fingers comes and mount on this particular part, the friction between the gripper finger and the gripper is reduced to a larger extent. This is one of the key advantaging features of this particular gripper family. Again, we have built this gripper to work for varied atmospheres. You can prevent this particular gripper is resistant to various types of greases, various types of oils, or any kind of lubricant which is present in the industries. This is IP64 industrial protection class 64. 64 is specifically used for dust and dirty environment, or when you're operating the gripper inside the water, or any liquid is there, any kind of grease, lubricant, any liquid is there, this particular gripper is suitable to operate in such drastic conditions. Yeah. See, the one more advantage feature of this is, as I said, the body of the gripper is completely steel and the guidance is steel on steel. The wear and tear is reduced to a larger extent. You can use this gripper up to 30 million cycle. When I say 30 million cycle, is 30 million times opening and closing of the gripper. Opening and closing is considered as one cycle. So similarly, 30 million cycle, this particular gripper can be used. And this is the highest life cycle of the gripper which is available in the current industry, or in the current market, what I can say. Nobody has this particular life of the gripper. This is 3 times better than anybody in the market. Yeah, moving ahead, as I was talking, the important feature is this particular wedge mechanism. This is a wedge mechanism. As you can see, whenever you pass the pneumatic air, this moves up to push the piston. So the angle here is reduced to a larger extent. This particular angle is reduced so that the contact is increased. So the movement is very fast, and the finger can be used for a larger extent. Yeah, this is the overall features which is being addressed in one single slide, that what are the key features of this particular family of grippers. Again, to sum it up, we have again 3 varieties in this particular 5000 series. IP40, IP60, as well as IP67. The only difference is IP40, this particular gripper is suitable for clean room applications. This particular gripper is suitable for dust and dirty environment. And this particular gripper, you can see, which is completely enclosed, is suitable for very harsh environment, for hot forging applications or very high temperature applications, or the gripper has to go inside, completely deep inside the water, and then has to perform the operation. So this is suitable in those kind of applications. Moving ahead, we have the intelligent grippers or the hybrid grippers in the family of 5000. Why we call this particular pneumatic gripper as intelligent pneumatic gripper, intelligent pneumatic gripper or the hybrid gripper? Why we say that? Why we say that? Because see, for a pneumatic gripper, you would require the pneumatic valve or a flow control valve and a sensor to understand whether the gripper is open or closed. To all these accessories you would require for a pneumatic gripper. Whereas for a pneumatically intelligent gripper or a hybrid gripper, this both will be inbuilt inside the gripper. The sensor will be inbuilt as well as the flow control valve or the pneumatic valve, it will be inbuilt inside the gripper. Yeah, this is how the gripper, the intelligent grippers or the hybrid grippers look like. This will help you in reduction of the cycle time, and it increases the production time by, let's say, 30%. Again, it is a pneumatically driven gripper, but you have a IO-link technology in it. IO-link technology will help you in understanding whether the gripper is closed or open, or in other words, it help you in sensing the component, whether the component is being gripped or not. So this particular feature is inbuilt inside this particular gripper. And one more important feature is you can adjust the gripping force. When I say the gripper, it should have a certain gripping force to hold a particular component. Let us imagine you want to hold your phone with the 2 fingers. You would require a certain force to hold your phone. Similarly, with respect to grippers, grippers also would require a certain amount of gripping force based on the weight of the component. Let's say now you are holding your phone with the 2 fingers, you would require different gripping force, and the weight of your phone varies. Now let's say you're holding a 10 kg stone with your 2 fingers. The amount of force you would require to hold the stone is little more higher. Similarly, we have varied ranges of grippers for different set of weight of the component. Yeah. Now, this particular slides show you about how the connection of the IO-link is available and how you will need to supply the pneumatic air. This particular point, here you can see, this is the port wherein you need to supply the pneumatic air, and this is the cable which is coming out, which can be taken as a feedback. So this particular feature which I explained earlier remains the same here as well. This pneumatically intelligent gripper is also called as hybrid gripper. I request everyone not to get confused with the hybrid gripper and the intelligent pneumatic gripper. Both are one and the same. Yeah. See, this particular chart gives you a clear idea of what is the difference between intelligent pneumatic as well as electrical gripper. You can see now this is wall dependent, pneumatic wall dependent, but this is not pneumatic wall dependent. And this is IP64 available in IP67. Gripping force safety, yes, there is a gripping force. Let's say suppose there is a sudden power cut, then the gripper should not drop the component, because it will damage the entire system. So there is a mechanism, there is a spring mechanism inside the gripper which will hold the force and will help you in retaining the component. Yeah, these are some of the ranges I was talking about. The gripping force ranges from 330 Newton to 2890 Newton. This is in 2 jaw, and in 3 jaw it starts from 740 Newton and it ends up to 7160 Newton. And the stroke per jaw, the opening distance from the 0 position, what will be the maximum opening? We have a maximum opening of 10 mm per jaw, which means a total opening of 20 mm. Similarly, it is 10 mm per jaw for a 3 jaw gripper, a total opening of 20 mm. So that is the movement of your fingers or the jaws. 10 mm per finger is the movement of your jaws. Yeah. Now, this particular slide shows about how the connections can be made with respect to the pneumatically intelligent gripper. You would require an IO-link master. This is your IO-link master. this IO-Link master is connected to the PLC or any type of controller. This IO-Link master just acts as an interface between the gripper and the controller. This is just a simple layout of the connections of the intelligent pneumatic grippers. Again, the IO-Link masters can be from Beckhoff or can be from Siemens, can be from Mitsubishi. Any make of IO-Link master you can use, and it is compatible with all the makes of the IO-Link masters. Yeah. Now moving ahead, we talk about the exclusive electrical grippers. The supply required to actuate this particular gripper is 24 volts electrical supply. And why we call this particular gripper as the sophisticated grippers or the industry 4.0 grippers? Why we call about these grippers? Yeah, you can see here the advantage of electrical gripper over a pneumatic gripper. For a pneumatic gripper, what are the things you would require? One is a gripper, and you would require a sensor, you would require the pneumatic valve, you would require a pneumatic service unit, and you would require a signal splitter to connect it to your controller. These are the things which you would require with respect to pneumatic gripper. But whereas in electrical gripper is directly connected to your controller. All these features, the sensor, the pneumatic valves, all these features are inbuilt inside this particular gripper. And the connection of the electrical gripper to your PLC is through a single cable. And this cable is used for data transmission as well as for the transmission of the signal. Both the ways, the single cable is used to transmit the signals. Yeah, the connection again remains the same for electrical gripper. You would need a Y connector, which one connection would go to the IO-Link master and one more goes to your power adapter. And then from the IO-Link master, it is connected to your PLC. This is just a connection of the electrical gripper to your controller. Why would you might have the question that why we need to connect the gripper to the controller? The controller is the thing which controls the operation of the entire system, not only the gripper, the entire system, the robot. The entire cell is being controlled by the controller. So each and every component is connected to the controller. Similarly, the gripper is also connected to the logical controller. So now I'll just summarize about the gripper family 5000. We have studied about the pneumatic grippers, wherein the actuation is again with the help of 6-bar pressure. Hybrid grippers or the pneumatically intelligent grippers, wherein the actuation is with the help of pneumatic air and you will have electrical feedback. Electrical feedback and the electrical grippers, the complete electrical grippers, the industry 4.0 grippers, wherein the actuation of the gripper is with the help of 24 volts, and you will have the feedback, you will have the inbuilt sensors and all the components inbuilt in one particular gripper. So moving ahead with the angular grippers, what are the advantages, features of angular grippers over the parallel grippers? Because why I'm making here the comparison is it will make the understanding of the parallel gripper as well as the angular gripper pretty much clear. So I'll just demonstrate the angular grippers in comparison with the parallel grippers. So parallel grippers, the opening of the gripper is in a parallel fashion. Now in an angular gripper, as I said, the opening of the grippers is in angular fashion, 0 degree, 15 degree, 90 degree. So that will be the opening fashion of this angular grippers. This again, angular grippers has a 30 million cycles of maintenance free cycles, and you would not require any maintenance until 30 million cycles. This is very robust, built for very harsh and dust dirty environment. All these features are also involved in this particular series. Yeah, see, you have seen the parallel gripper. These are the jaws which are opening up in the angular fashion. You can see the wedge is made in an angular fashion. This makes the opening of the gripper in an angular fashion. On supplying, this particular cylinder will push this piston, and then the piston further moves this wedge and the gripper opens in angular fashion. So just You can just have a look at this particular point. This particular point is a positively driven lever mechanism, which will help you in opening of the jaws. These are the gripper jaws where you can mount your gripper fingers. These are the gripper jaws, I would say. And this is the pneumatic, double acting pneumatic cylinder we have, which will help you in moving the cylinder up and down so that the gripper opens and closes. Yeah, this particular image shows you, this is your crankshaft. I think many of you have seen this image. This is your crankshaft, which will help you in converting your linear motion into rotational motion in an automobile industry. So this particular crankshaft is being handled with the angular gripper. This is how the gripping takes place. The advantage of this particular gripper when handling the crankshaft is this particular, we call it as a journal. This is your journal. So the dia of the journal usually varies. We have a lot many variants in the industry. Lot many variants of dia are available, or this particular journal dia varies from a large variant, let's say from 30 mm to 250 mm. So there's a larger difference of this particular dia. So to handle such larger variants, you can use this angular gripper because it can accommodate many variants in this particular opening and closing of the gripper. I'll tell you a little more in detail about this. So now, as I said, now we'll have a comparison with the parallel gripper. Let's say this is one gripper, this is a parallel gripper, and this is your angular gripper. Now I'm handling this particular component. Now my stroke per jaw is 13 mm. This particular jaw moves 13 mm in this direction and 13 mm in this direction. This is parallel gripper. How about the angular gripper? The opening will be in angular fashion, right? 15 mm, the 15 degree is this particular, the opening of this jaw is 15 degree. The opening of this jaw is 15 degree in this side and 15 degree in this side. So 15 degree, when I convert into mm, it is 71 mm. So you can accommodate a larger variant, as I said. Now this is one variant you're handling. Let's say this is 20 mm. The dia of this is 20 mm. And if I want to handle a dia of 30 mm, it would be difficult for me to handle a dia of 30 mm. Why? Because my total opening of the gripper is 26 mm. That is 13 mm this side and 13 mm this side. So the total opening is 26 and I cannot accommodate a component which is having a dia of 30 mm. So in that case, that particular variant can be handled easily with the help of this angular gripper. This is the advantageous feature of this angular gripper. It can accommodate many number of variants or different number of sizes. If I have to say it in another way, the different number of sizes of the component can be accommodated or can be handled with a single gripper. But if you go with the parallel gripper, you need to install one more gripper with a higher size to handle a different component. So the number of grippers goes on increasing. But for a cost effective and economical way, you can also use the angular grippers when we have multiple variants. This is just an example. Yeah. Stroke comparison I was telling, for a 8 mm, this is for this particular series of gripper, we have 8 mm stroke per finger, wherein this has 45 mm per finger. So the stroke increases by 5.5 times when you compare parallel gripper and the angular gripper, as well as the cost is also 5 times lesser than the parallel gripper. The cost of this particular angular gripper, if I have to talk on the commercial part, the angular gripper will be on a lesser side when you compare to the parallel side. This would be more cheaper than the electrical gripper, I would rather want to say. So these are some of the advantage features of angular gripper over parallel grippers. Yeah. Now we will study a little more in detail about the electrical grippers, which is the industry 4.0 gripper. You can see the series GH6000IL. This is the best in class gripper we have. This is one of the topmost grippers we have. Why we call it as a topmost? Let us see now. Okay. Why we call this particular gripper as a topmost gripper, because you can have the control over the gripping force as well as you can have the control over the stroke. Now I'll give you an example. Now imagine you have five different components. Five different components. Let's say a steel rod. These are the components I'm just telling you. One is steel rod, one is a glass jar, one is a wooden box, and one more is a coin, and one more is a metal plate. So all these five different components you have. I just want you to imagine all these five components: a steel rod, a glass jar, a metal plate, a coin, and a wooden box. So for five different types of components, you would require five different gripping force. You cannot have the same gripping force as handling for a steel rod with the glass jar, because the glass will break. If we apply more force, the glass will break. So this particular gripper, why we call it sophisticated, because this will help you in having the control of the gripping force. So you can adjust the gripping force according to the component. Now, if the wooden box comes, you set a different gripping force. Now the glass comes on the line, then you set a different gripping force. Now steel rod comes, you set a different gripping force. So you can have the complete control of adjusting the gripping force. As well as when I say all these different components have different dimensions. So the stroke also should vary, or you should have an adjustable stroke. The position or the stroke adjustment is also available. You can adjust the stroke as and when you require based on the components you're handling. When you can handle up to 32 different components, 32 different components of different size and weight. All 32 different components can be completely different. May it be the physical, the appearance, or the weight of the component, anything it might be. 32 different components can be handled with one particular gripper. You can monitor as well as you can control. Monitoring and control is both possible with this particular series of gripper. Yeah. And these are some of the available ranges of grippers we have in this particular gripper. GH 6000, the maximum stroke available is up to 80 mm per finger. So total opening will be 160 mm. So minimum starting from 40 mm and up to 80 mm is a stroke available. So whenever I talk about stroke, it is a stroke per finger, not the entire stroke. The stroke per finger. So when I say 40, the total opening will be 40 mm. Yeah, the connection again remains the same. The grip from the gripper, it is connected to the IO-Link master, and from the IO-Link master, it is connected to the PLC. IO-Link master just acts as the interface between the gripper as well as the controller. Why some people might ask why I would require IO-Link master in between. Instead, I could directly connect it to the PLC. Only the communication, what this gripper says, will not be understood by the controller. This communication is manipulated, or in terms I could rather say it as it is converted to the understandable language for the PLC. This IO-Link master converts the language which is suitable for the PLC. So that conversion is done in this particular IO-Link master. So the language of gripper and the PLC controller is not matchable. Sometimes in that case, you would require this IO-Link master as a mediator to communicate between the gripper as well as the controller. All right. Now we have one more series of electrical gripper, that is GEP 2000. What is this particular gripper says about? This gripper is very compact. When you have very less installation space, or when you are handling very small components or very minute components, for example, in pharmaceutical industries, or in food and beverage industries, or FMCG industries, where the components to be handled are very lightweight, and the installation space is also is of a little constraint. In that case, you can use this smart compact electrical gripper. Again, we have two versions in this. One is IO-Link version and one more is the digital IO version. First, let us study about the IO-Link version. The connection again remains the same. This picture will give you the clear-cut idea of how the connection is there. There is only one cable coming out of the gripper. This cable is connected to your IO-Link master, and from the IO-Link master with the Profinet or any kind of field bus, you need to connect it to your PLC. This is how exactly the connection of the electrical gripper for a IO-Link version is done. Again, as I said, in the electrical gripper, we have two versions. This is version number 1, IO-Link version, and this is one more version. There is a digital IO. The only difference between these two versions is here in this particular IO-Link version, you can have the control over the gripping force. You can adjust the gripping force through the help of this PLC. You can set the value of the gripping force in the PLC. Whereas in this particular digital IO model, the gripping force is adjusted mechanically with the help of Allen key. So 5 different levels of gripping force adjustment can be done mechanically with the help of this Allen key in case of digital IO. The actuation of the gripper remains the same. By 24 volts only the gripper is actuated. Only the gripping force adjustable is here mechanically. Here it is done through the help of the logic controller or the PLC. That is the basic difference between the IO-Link as well as the digital IO. Yeah, you can see here the connection of the gripper is directly to the PLC. You can connect the gripper directly to the PLC and you won't require any IO-Link master in between. Why? Because here you are only monitoring the data from the gripper. You are not adjusting or you're not controlling anything through the controller. There is no control here. Only monitoring is done with the help of this PLC. So that is the reason there is no IO-Link master in between. It is directly connected to the gripper. Moving ahead. Yeah. Now we have studied about the gripper family 5000, the GEH 6000 series, GEP 2000 series, the pneumatic grippers, the electrical grippers, the industry 4.0 grippers, the hybrid grippers. So all these are one set of grippers, and we have one more range of grippers. These are the complete range of grippers. I have just put a picture of 1 series, and we have a lot many variants in this. This is GPP 1000 is one series, or it belongs to one family of grippers. MGP is one family of grippers. This the feature is this is very compact, very economical, and for very smooth applications, very clean room applications, this can be directly used. This saves your installation space. And one more type of gripper is the long stroke gripper. This is the long stroke gripper. Why we say long stroke gripper is the gripper opening will be up to 200 mm per finger. The total opening will be 400 mm. When you are handling a bigger component of lesser weight, this can be used to handle certain component. For a larger diameter or for a larger dimension of the component, you can use the long stroke grippers, wherein we have the maximum available stroke is 200 mm per finger. The total opening would be 400 mm. So that is one type of gripper we have. This is a 3-jaw gripper again, and this is one more fantastic gripper we have. What is this? The feature of this is this rotary gripper. We call it as a rotary gripper, wherein the gripping and rotating is done with the one single component. First, let's say you have an application wherein you have to pick the component and you have to rotate it to 90 degrees and place it on the conveyor. This is just an example. I'm putting it across to you. So in this kind of application, this particular gripper will grip the component, and this is the rotation part. This gripper rotates to 90 degree or 180 degree and then places. So certain kind of application, only one single component does 2 jobs. One is gripping as well as one is rotating. Both the jobs are done with the help of this rotary grippers. And these O-ring assembly grippers, separators, these are rotary units, are some of the end of the arm tooling. The specialized grippers, what we call, were used specifically for special applications. For example, O-ring gripper is used for assembling the O-rings. Yeah. Now we have one more special purpose gripper. This is the magnetic gripper. This is used for handling the sheet metals or the ferromagnetic components. Here, you need to actuate this gripper with the help of pneumatic 6-bar pressure, and this is the part wherein the component comes in contact. This particular area gets magnetized and demagnetized on supplying the pneumatic air. So this comes in component with the sheet metal or any ferromagnetics, and it can grip the component and it can be used for handling applications. I'll show you some of the application images. You can see this is for an automotive industry, which we supplied in Chennai again, to be very precise. This is for use for door locks. You can see there are a number of magnetic grippers here. 1, 2, 3, 4, and similarly on the other side. These magnetic grippers are used to handle this particular door locks for a car, for an automobile actually, for a passenger car. And this particular gripper can handle up to 42 kg with one single gripper. So all the ferromagnetic components can be handled with the magnetic grippers as well. So let's say you have a flat sheet and it would be difficult to handle with the normal grippers. You can use this magnetic grippers to handle such kind of components. And this is one more, special purpose gripper we call as a needle gripper. This is specifically used for handling the fabric or gunny bags. You can see this gripper. Now it is handling this particular cloth or a fiber with the help of two grippers. There are two grippers, one and this is gripper 2. This is how the operation of the needle gripper works. What it does is you can see the needles coming out here. On supplying the pneumatic air, the needles come out and pierce into the cloth or a fiber, and then it picks the component. And the length of this, the needles can be adjusted again. You can see the number 1, 2, 3, 4 over here. This is the rotating bar which can rotate and adjust the length of these fingers, which will pierce the fabric, and then it can grip the component. Now, this is human collaborative gripper. Nowadays, you must be more familiar about the cobots, because the days are going to come wherein the robots and the people or the humans starts working together. Humans and robots will work together in the coming future. That is the next generation factories will have these cobots. We call as collaborative robots are called as cobots. So the cobot cannot be called as a collaborative unless the end of the arm tooling is collaborative. You can see here the robot and the humans are working together. So it should not damage the human, or it should not affect, or it should not harm the human when you are working along with the robots. So we have these collaborative grippers which will help you in working along with the cobots. For example, if the component is, let us imagine that the gripper is the gripper is approaching the component. It is about to grip the component. Now you insert your hand in between the gripper will stop. It has got inbuilt torque and force sensor and a camera which will help you in understanding whether there is a human intervention or not. It will not damage or it will not harm the humans when the human is working along with the cobots. Yeah, this is how it is. See, this is a robot flange, the cobot flange. We have a system adapter module, and as I said, force and torque sensors, camera and communication module, which will help you in sensing whether there is a human intervention, when there is any obstruction in between. So this is just how exactly the collaborative gripper works. This is compatible with all kinds of cobots. Yaskawa, you can consider any cobots. This can be directly mounted, or this can be compatible with all the cobots. And we have been awarded one of the most prestigious German award for this particular design of this gripper. The Red Dot German award is being awarded consecutively 3 times for Zimmer for the design and development of this particular collaborative gripper. Yeah. See, we have the features on this particular gripper. There is a LED light display on this particular gripper body. So which specifically gives you the information. Let's say if there is a blue light glowing on the gripper, it says that the gripper is in standby. The person little away from the gripper can also see whether there is a gripper is operating fine or not. If it shows a yellow light, then the gripping is in process. It says that the gripper is about to go and grip the component. If the LED light shows green, then it says that the component is being gripped. If it indicates red light, then there is some sort of error in gripping. So these are the indicators which are available on the body of the gripper, which makes it more special and more attractive in terms of Industry 4.0. And last but not the least, we also cater to the complete system technology. When I say system technology, we take care of the complete end of the arm tooling, from the robot to the entire whatever comes below the robot. Entire system is taken care by Zimmer. We developed more than 7,000 systems till now. Most of them we have supplied to the automobile industries. One example you can see here, this is the crankshaft being handled by two grippers, gripper 1 and gripper 2, and you have a rotary model on top of it which will help you in rotating. This is the entire EOT which is being built by Zimmer. And we, as I said, we also build the complete systems for the robotic cells. What is the advantage of building the system is we take care of the responsibility, we take care of the maintenance of each and every component, and we assure that the design and the documentation is taken care by a Zimmer Group, and the complete system we give a 10 million cycle of maintenance free. Entire each and every component, the life is around 10 million cycles. So we take the complete responsibility of the EOT or in building the complete system, and we have got good expertise in building these systems, and we have built more than 7,000 systems till now, and it's good to be it's good to build a system actually, because it will be more reliable from the robotic cell perspective. And these are some of the industries we are working with. We are working with automobile industries, we are working with FMCG industries, food processing industries, machine tending industries, or the electronic chip handling applications or PCB handling applications. So these are some of the applications which we are working in, or some of the industries we have already worked. So okay, all right, sir, and that's it from my point. Once again, I would like to thank all the participants for your time, and Ligmuran sir for giving this big opportunity for us to demonstrate about the end of the arm tooling. I again sincerely thank you for this opportunity. Over to you, sir.
So thank you, sir. Thank you so much for this session. This way of power-packed tech talk on the latest development of end-arm tooling segment. So we appreciate the deep insight that we were able to garner from the session. Thanks again for taking the time of your schedule to host the session for our audience. I thank Zoom, Zimmer India also, and all Lenin and Mr. Zimmer and all the Zimmer team. I thank from AGIIT team and Access Global team once again. We thank the audience by being the great batch. So we look forward to seeing at the next week webinar. Soon I can think this kind of series we need to go again because of the OE support. So thank you so much, sir. So being with us, happy to give the schedule for us. So thank you so much.
Thank you, sir. Thank you so much for all the opportunities, sir.
Yeah, thank you, sir.
Thank you, everyone.
The video, subscribe to the channel and press the bell icon for latest video updates.